This lesson has been developed in the framework of SCILED project.
Module 1, Footwear Performance and Comfort. Unit 3: Fitting and Dimensional Comfort.
Lesson 3.1. Static and Dynamic Foot Measurements. This lesson is structured as follows.
Basic concepts and foot measurements. Fitting aspects. Methodologies and tools for determining comfort aspects.
Static and dynamic foot measurements.
Our locomotive system fulfills the necessary functions to be able to move from one place to another by walking, running, jumping, etc. Within the locomotive system, the feet are of special importance. To protect ourselves from the ground we wear shoes, and this is very different from a thermal covering protection like the rest of the locomotive system. When we put on shoes we totally change the physiology and morphology of our feet.
Foot measurements are the necessary parameters for the construction of lasts. Lasts are the base on which the footwear is manufactured. For the design of lasts, the morphology of the foot and how it changes while walking, the aesthetic toe addition, and finally the functionality of the footwear including its construction materials, are taken into account. We can divide foot measures into longitudinal, transversal, height and girth measures. Girth measurements can be longitudinal and transversal. Among the height measurements, we highlight the height of the first toe, big toe, as this measurement is very important for a comfortable fit.
The fundamental dimensional difference in the foot between dynamic and static conditions can be seen in the figure, where the most influential parameters are displayed. We refer to static conditions when we are standing, and dynamic conditions when we start walking or running. At the level of parameters, a very interesting distinction is that of weight-bearing or non-weight-bearing conditions.
This affects the measurements displayed in the figure, thus increasing their value when the foot is weight-bearing, especially the total length, internal arch length, width and girth. It is when the foot is weight-bearing when the parameters really change, and when the foot is in motion especially morphological changes occur in the metatarsophalangeal joint area. Fitting aspects.
Footwear is built according to its intended use. Depending on the functionality of footwear, the materials will be different. Of course, in order to get a good fit, the last will be built differently at a dimensional level, depending on the type of footwear. For example, a casual shoe is quite different from a professional shoe, as both require a totally different last.
Methodologies and computational tools for determining comfort aspects, commercial and academic.
3D digitizers are undoubtedly a perfect tool to know the morphology of the foot. The most interesting ones are those that make a laser scan. Using this technology, the small involuntary movements of the foot when digitizing go unnoticed. The result is a large three-dimensional point cloud. The digitizing system normally captures the information from the feet in a standing position, completely flat to the ground. The construction of a last with the information from the digitizer is not a direct transformation. We need complementary applications to help us design the last and then build the required footwear. Among these applications we should mention the digitizer, which provides us with information on the morphology of the foot and anatomical parameters, CAD software for lasts and CAD software for insoles, which efficiently help us build the last. The assessment of comfort in general is very subjective. However, apart from the fit, whose general assessment can be very subjective and complicated, there are other more measurable comfort factors. This is the case with thermal comfort, the weight of the footwear, the pressure distribution, the footprint, etc.